Hello everyone, my name is Isaias. Yeah, I work at Enoda. So Enoda is a company based in Edinburgh, not so far from here, at Quarter Mile. And yeah, we operate on the energy sector and we share main of the pain points for the previous slides. Because we are dealing with real world problem, we are using blockchain to solve some of them. But energy is also national security, so a lot of regulation there, privacy concerns, and many other things. So today I'm not diving into the technicality of blockchain, and no, the idea is to show a use case of this technology, how it can leverage the benefits of it. So, my background is computer science. I have been working in Enoda for 4 years already. Initially, I have worked close with the hardware team. We will show you very soon. It's been almost a year that I joined the Ensemble team. We'll talk about what Ensemble means in a moment. But essentially, we'll talk about technology, hardware side, the orchestration layer where we use blockchain, and then we'll understand how we can unlock grid full potential. And we'll talk about a lot of problems we are having today, and yeah, hopefully we've managed to solve some of them. Right, so what do we do? Why do we exist, right? So I don't know if anyone is familiar with the problems that we're having now with renewables, grid instability, balancing market, electricity bill going up. All those problems, they are related with the energy transition, right? Many of them, at least. And the purpose of the company is to address some of those problems. Essentially, we come up with technologies we will present in a moment, but the objective here is to make the grid more reliable. And if you make the grid more reliable, you reduce maintenance costs, operational costs, which makes energy more affordable for everyone, and that's the kind of the mission, the vision that we have. Let's talk about problems, because a lot of problems, and as an engineer, if you don't have a problem, don't have a job, right? So we work with the solutions for them. What we're having here is a three-phase sine wave, could be the socket that we have arriving here. And the blue one, doesn't look nice, does it? Ideally, you want a system, a perfect balanced, clean sine waves here, and anything else that we see translates into problems. The first one, let's talk about voltage regulation or over voltage. A couple of months ago, we had blackout in Spain because of a lot of decentralized generation, and that essentially means that one of those sine waves, or maybe three of them, they increase in magnitude. So the peak of that voltage can potentially go above the grid code, the regulation. And not necessarily a problem, that's just expected. If you have heavy load, they will drop a little bit, but if you have a lot of low decentralized generation, they might increase. Not a problem, but the power grid itself has a strong self-protection mechanism. Essentially, anything out of the normal operation, equipment just starts kicking off, disconnect for self-protection. So in Spain, for example, that amplitude was too high, some of the equipment started tripping, disconnect from the grid, in a couple of seconds, you get a blackout. Blackout, not so great for the economy, not so great for people in hospital, etc. This is one of the problems. We can have harmonics, translates into noise, we can have a lot of decentralized generation, but also decentralized different unpredictable load profiles. And all of those items here are problems that we're facing 24/7 every single day of a year. How do we solve them? I'm not diving into all of them, but essentially most of them, they are coming because the power grid is changing drastically. Historically, we had nuclear power plant, gas power plant, and so on and so on. And on the other hand, we have very predictable load, right? So you have the most unpredictable thing we used to have were people, making a cup of tea at home. Today, we have not only solar panels everywhere, decentralized generation, but we also have EVs and HVAC and so many things. Essentially, for the grid, we are looking very much to the last element on the right-hand side, the hertz, the frequency of the grid, which is just a product of consumption and generation. We have to keep those two elements in equilibrium all the time. So, if the load is heavier than the generation, we have more people consuming electricity, the frequency will drop. Frequency drops below a very tiny margin, the grid disconnects. If you have more generation than what you're consuming, it's like a motor with no load, just spin faster, the frequency goes higher. So those are problems that we solve. In the company, the backbone of the company, of our technology, is the prime exchanger, which is this little guy here, which is a little bit bigger than myself. Essentially, this device, this exchanger, it replaces a traditional transformer in the grid. So we have, on the one hand, in that device, that's that particular, we have medium voltage arriving, let's say 15,000 volts, transforming to 400 volts that we receive at home. Why is it so different? So essentially, inside of the device, we have active components. We have computers, we have sensors, we have power electronics, everything reacting and operating at a 20 milliseconds level, reaction level. And I was working with this device for quite a while on the software and control systems perspective, but essentially that device solves some of the problems that I mentioned previously. It will clean the signal getting dirty, having harmonics arriving, the voltage can get out clean, it can maintain the voltage within the limits, and those are benefits for DNOs, for the local grid, and improves reliability, many of things. So far, nothing about blockchain here, okay? Just to simplify, to illustrate actually, right? So the idea of the hardware, of the device, is that whatever gets in, we manipulate the magnetic flux on the core, on the ferromagnetic core of the device, and it gets clean on the outside. Since we have power electronics and computers there, we can just send a remote instruction to this device to do something. One of the things that this device can do is regulate the magnitude of the voltage. They can be higher or lower. Therefore, some of the loads, they can react, increasing or decreasing the load. This is the backbone of the technology. And where does it fit? So essentially, in this slide, you can see the Enoda's ecosystem. We have those exchangers installed across the grid, replacing traditional transformers. We have the second product of the company, which is Enoda Nodal Asset Management / Node Intelligence, which sits on those devices, collecting a lot of data, learning models there, data science, bring this data to our cloud. At our cloud, we do have Ensemble, which is a orchestration layer that will explore the flexibility of those devices and provide balancing services. That coordination layer is a blockchain-based system and we talk about that in the following slides. But essentially we can see where each element sits, and the goal of Ensemble is selling that flexibility to the market. Jump into us, blockchain, and why we are here. We need to talk about Ensemble, but essentially it's fundamental to understand those two pictures here. As I said before, if the load, how much energy we are consuming, is higher than what we are able to produce, the frequency of the grid will drop. Essentially, the way that the transmission system operator, the TSO, manages that is by, they have balancing market, where they will just pay people to inject power in the grid. Or they will pay someone like Tesco to turn off some of the fridges for a while to reduce the load. Then you bring the load consumption, the energy consumption and the generation back into equilibrium and restore frequency. On the other hand, if you have a lot of generation, essentially your frequency will go higher, and the TSO might ask some battery energy storage system to draw some power from the grid, or you ask some inverters or some power provider to cut off for a while to bring it back. So we are operating in this market, right? How do we do that? With the prime exchanger, the device, we can increase or decrease the voltage on the secondary side. That translates for some types of the devices that will consume a little bit more or a little bit less power for that specific period of time. So we can have an orchestration layer that is constantly checking those devices and also communicating with the TSO. And once we get a request, we can just share the request with the prime exchangers to increase or decrease the voltage there. And therefore we increase or decrease the load, we sell the balancing service. This is where we situate. That is extremely regulated. A lot of audits here. That mechanism is operating in some locations in sub-second delay. So anything that we do on chain, off chain, doesn't matter, has to react quickly. And then we come with Ensemble, right? Ensemble is that orchestration layer that that's implemented actually using blockchain. We are at Enoda using building on top of SUI, and it brings to us some of the benefits. Same thing as we have seen in the previous presentation. If something goes wrong here, off-chain in the UK will come to us like, show me the data. What went wrong? Who did something not expected? And who is liable about that? So transparency, immutability, all those things that we know from blockchain, that the blockchain gives us, extremely important. And also that's a fully decentralized system. So the TSOs manage the grid with regions in mind. Something that happens in Edinburgh, the decision is completely different from what happens in Glasgow, because we have the transmission lines from Scotland to London, for example, which are most of the time congested. That's why we use a blockchain, right? So it is decentralized. That's why we went for SUI as well. We can run some of those mechanisms in parallel, but essentially the key point is transparency and safety. How does it look like? So essentially we have decentralized energy resources, DERs, everywhere, which could be our device, could be, Tesco fridges, could be some data center or batteries, prosumers, doesn't matter. On the other end, we have the Ensemble core, blockchain based system that via smart contracts again implements all the market rules that we have to follow, step by step, following timelines, following everything. everything is stored there. Not privacy data, because this is not national security. In case of a war or anything, I cannot just go to on chain and see what is happening in each substation, which substation is more vulnerable, let's say. So we cannot store there anything. Zero knowledge, privacy, top one for us. And then we have the application running on top of that. So the application we see each participant here as with a wallet registered, getting paid in tokens. And what we have as a conductor and aggregator, as like a unified agent. That is the guy connecting physically with the national control room. In some places, like in Poland, we are literally talking about cables going to that because it's very, very regulated. But essentially, the D app is relying on top of the blockchain, implementing all the market rules, communicating with the devices, getting the availability, storing on chain only metadata, everything non-identifiable, selling that flexibility to the TSO, getting those instructions back, notifying the assets, keeping this communication open all the time, and at the end, if everything's fine, the TSO pays Enoda in fiat currency for the services provided, and we do pay the assets in tokens, which we call the quartet in our case, for the service provided. These are settlement. Later on, the asset owners, they can just exchange like fiat currencies by quartet spot tokens. Again, this is not a new problem. So since we have electricity, this is a problem and has been solved by different ways. But right now, things are getting more dynamic. We need dynamic solutions as well. We cannot just call anyone to do anything. So we use blockchain because mainly security, transparency, that's number one, but also scalability for us is a big thing because we have decentralized power generation, and we need decentralized solutions following the workloads. So with the fast path consensus mechanism gives us lots of benefits on that aspect, but also we have our in-house, we are working on that actually, our in-house zero knowledge proof mechanism. So essentially I don't have to save the raw data, I can use metrics like THD, the total harmonic distortion, or anything, and from there store on chain just the metadata. And compliance is also a big thing, probably for construction as well, I suppose. But regulatory people, they are not happy with blockchain in general, so we have to do a lot of work on that. So that is part of the European blockchain sandbox, essentially fighting on the other end. We fight with the technology, but we have a team in-house looking to the compliance and legal aspects of things. As I said, we have our in-house zero knowledge. I cannot give too much information yet because we are about to publish a white paper. That's the last slide. But essentially, instead of saving on chain the raw data, many problems there, too much data, privacy, etc. We have to come up with a personalized zero knowledge for that application. So we not only save the metrics of that, but we also need to save many things like if it's a battery, we have to save some information, state of charge, state of health, and things like that. If you're using a prosumer like a telescope, reducing the load and so on, you have some other aspects. So implementing the market rules into smart contracts, but also making sure that you are not storing on chain any private information, that's kind of a big big thing there. How do you unlock the grid full potential? I'm not getting into details, but essentially you must come up with a decentralized orchestration layer to react as quick as possible to grid instability. And it has to be scalable, has to bring safety, and so many things. So that's where we sit. That's where I'm working with Ankit for the last year, building that setup. Yeah, I'm just over time, but essentially, if anyone has any question, please let me know on the break or later on. But I know that we are also hiring all the time. So not only from the blockchain world, but also software developers, data science, power electronics, who knows, electrical engineers. So please feel free to get in touch with us in the website or LinkedIn. Thank you.